I guess for most of you, I will be from another planet, but I will try to keep simple our understanding, and I will speak about Birch bark extractives and their potential, and also have slides from the Latvian State Institute of Wood Chemistry. We are located in Latvia, in Riga, and our mission is the development of knowledge-based and environmentally friendly low-waste technologies for obtaining competitive materials and products from wood and other plant biomass for sustainable utilization of natural resources, including forests. So, and our strategy is based on industrial research, innovation, and bioeconomy policies, and research and development requirements from forest, agriculture, and wood processing industries, which allowed us to identify three excellences. One is wood materials. It's a wider use of wood and wood-based materials in building and construction by refinery. By means of valorization of European and local plant biomass and green chemistry to use renewable feedstock as raw materials for synthesis and production of chemicals and polymers. I am representing the biorefinery. I'm also from the biorefinery laboratory of our institute. And I will speak about birch bark. It's widely used in the furniture, pulp, and plywood production in Northern Europe. And it consists of birch outer bark. Maybe from the beginning it looks like it's not so high content of this outer birch bark, but if we take into account that plywood producers can produce, for example, 17 to 18,000 tons of birch outer bark, that it's a huge potential. And we think that other uses and producing of energy may be more attractive. Therefore, the aim of our group was to increase the utilization efficiency of birch bark and to inform also the audience about this wide scope of high added value products which could be produced from this valuable raw material. And we identified two problems, that birch bark is burnt in boiler house. So we think that money is burnt as well, because birch outer bark contains great amount of products. And another problem is synthetic binders, which are the most commonly used, for example, in the manufacture of glued wood composites. They contain toxic compounds such as formaldehyde and phenol. These composites actually are toxic to humans, both in the process of their manufacture and in the exploitation of finished products. So also thanks to these compounds, we know the term thick building syndrome. And this is very important in the sensitive areas like hospitals and the public places for children, for example. So in this slide, you can see that pictures of birch bark before extraction and after extraction. Inside the cells there are extractives, and this cell walls comprises of polymer like suberin. I will not go in deep. And also there, I will not explain maybe the structure of all these compounds, but about the application, these extractives, betulin containing extractives, they have high biological activities, therefore they can be used for cosmetic as an emulsifier, antioxidant, preservative. Also, they can be remedy against several diseases and virus infections, while the residue polymer, natural polymer suberin, they are rarely formed in nature and therefore very difficult to obtain synthetically, and it's interesting raw material for organic synthesis, also for cosmetics, adhesives, and polymer industry. And regarding to extractives and betulin, we have our local plywood producer, where is a lot of birch outer bark. So we did contractual research and developed a technology for betulin production to an industrial level, and also produced this betulin lab has been completed, this experimental plant, and also regimes adapted for industrial production. Also, we continue to work with this betulin in science more, And in simple words, it is possible to obtain homogeneous emulsions from this purified and unpurified metal in hydrogels. Therefore, it's even more potential to be used in medicine, food, cosmetics, and nanocatalysis, or even as a drug carriers, because this high surface area. If we go back to suberin, yeah, it's a complicated compound, and after depolymerization, it's a cutting of the structure. We obtain a mixture of several compounds. I think I will not mention all these compounds for you, not to be afraid of. And we are doing the characterization. It's really challenging to characterize all these natural compounds. And but more top applicable things, we developed adhesive from these subrinic acids, and for particle boards and also for plywood. And the good thing that these adhesives have several good advantages, because they are environmentally friendly, health friendly, efficiency. They have moisture resistance, which is very unique from natural products, and also innovative material with good mechanical properties. And in comparison with other natural binders, our act as it is without any additive or modifiers, and this means that it is completely ecological product, and we put it on the top of the pyramid. Also, there is a great potential because the market of green buildings is increasing still, and this trend is very popular. And but not everything is so nice and shine. Still, we have high pressing temperature, which is not good for wood-based composites. So we started to solve this problem using equipment, and the results. We tested several catalysts and also made real plates as references, and got some results about the best catalysts, and it was possible to decrease this pressing temperatures, but just by 20 degrees. So we need to continue the research to reach lower temperature. And this is our future job. Also, we tried these subrinic acids in biopolyols for polyurethane foams. It can be used for insulation material. It's also possible to replace synthetic part of this polyurethane foams with increase this total renewable material content up to 20%. And they showed autocatalytic properties, and therefore approved the potential ability of these subrinic acid-based rigid polyurethane foams. Production as thermal insulation material, but also not everything is very shine and good. The viscosity of such polyols was too high, and so we are also a lot of problems to do in the next project, and we are looking for some solutions. One was lyophilization. It showed a slight improvement, but we think that it's not the best industrial solution for drying of this subrinic acid. So still a way must be found to improve this viscosity and to integrate this subrinic acid mixture into polyurethane formulation, keeping the same mechanical and thermal properties, and to substitute these petrochemical adducts. Another is subrinic acid fractionation, because there are also the fractions with lower molecular weight. It also is showing some promising results, and it's one of the things we are doing at the moment. So it was possible also, varying by the polarity of solvent, change the composition of these fractions. And another application of these subrinic acids could be for impregnation of bulk wood. We tested several compositions of products and byproducts of this subrinic acid production. We also have in one aeronet project bark build, and we are testing this, and also find some solution how to impregnate these subrinic acids into wood, and give the wood the property of to this water resistance and also for fungal resistance, we hope. This is also unique. And another property of subrenic acids can be used in wood polymer composites. It's a polymer extruded together with wood, and we found out that the subrenic acids act more effective as a more effective lubricant than the synthetic zinc stearate, and also decrease the wettability of the composite performing the function of an adhesion enhancer. So we see a lot of potential for subrenic acids. I know that also such subrenic acids are in Portugal, in a oak cork, and you also are working on such chemistry. So it would be nice also sometimes to compare our results or some competences. I'm sure that it's a good way to cooperate sometimes. But these subrenic acids are unique because they have polar and non-polar adhesion. Therefore, it's also they exhibit good adhesive properties, including high bonding strength, water resistance, and compatibility with various hydrophilic materials, and therefore they can be incorporated into polymers and enhance their properties. Also, they exhibit antioxidant and antimicrobial properties due to polyphenols in the structure, and also can be used as superior friction reducing agents, and also interface modifier between the hydrophilic wood particles and polymer matrix, and also to enhance the dimensional stability. And of course, as bio-based additives derived from renewable non-food plant sources, subrenic acids offer an environmentally friendly alternative to conventional additives. So we have skills, knowledge, and we are very open to cooperate. If you see, we can not process not only birch bark. We are in our institute working also from agriculture, straw or chives, hemp, any imaginary biomass, cellulose and lignin containing residues. We are very interested in collaboration to convert them in the products with higher added value. So thank you.